We have some integrals over here, and in this video we're basically going to be learning how we can solve these difficult looking integrals over here. And it's actually really simple because you already do know this general form of an integral that looks something like this. And all we're going to try and do in this video is we're basically going to use some properties to turn all of these integrals right over here into this form. And that is what you want to do whenever you're solving integrals. You want to convert the difficult looking integrals into something you already know how to solve. Okay, so let's introduce you guys to some integral properties. Now, if you look at the first integral, so it's 1, 2, and then it's x squared plus x dx. Okay, so I want you guys to know that whenever you have pluses or minuses, so whenever you have pluses or minuses in your integrals, then you can split the integrals. You can split the integrals. So that's what we're going to do over here. We are going to split these integrals where we have the plus and minus sign, and that's going to look something like this. So that's going to become 2, 1 dx, and we're going to have the x squared over here, and then we're going to have the plus sign, and then we're going to have this integral over here. So that is going to be x. So all I did is I basically split the integral into two integrals where I had the plus sign. So if you have a plus sign and a minus sign, then you have the split property. Now you want to use the split property because it can convert integrals like this into integrals like this. Now let's solve the second integral right over here. So we have the second integral right over here, and we're going to try to solve it using the same technique. So you can clearly see a plus sign. Now you're always trying to look for those pluses and those minuses because you're trying to simplify this difficult thing into that thing right over there. So we already see a plus, and what we're going to do is we're going to split this integral into two parts. So it's going to be, the first part is going to be this, and then the second part is going to be this. And then we are going to have our x divided by 5 over here, our 10x raised to the power 3 over here, and we're going to have our plus sign over here. Now you can see that this already looks way easier than this thing right over here. This right over here is more similar to our general form that we know how to solve. However, we're not done yet. Why? Because you can see that in our general form we don't have any numbers. So if you take a look at our general form, you can see that the x does not have a coefficient. Over here in our example, we have a 10 and we have this thing right over here. So what do we do about these? Now, I'm going to write this in a different way. So it's just going to be, this thing is going to stay the same, but this thing is just going to change a little bit. So I'm going to write it as 1 by 5 times x, and I can write it like that. Okay, that's just simple algebra right over there. And with that, what I can do is, if you realize that now I have a coefficient over here with x raised to the power 3, and I have a coefficient over here which is 1 by 5. And so the second integral property that you need to know is that the coefficients can go outside or come inside of the integral. And that's exactly what I'm going to do over here. So I have a 10 and a 1 by 5. I'm just going to erase these guys over here, and I'm going to take them outside of the integral. So that's going to be my 10, and that's going to be my 1 by 5. And now all you got to do is, you can see that this thing right over here and this thing right over here is exactly what your general integral form is. So you solve this and you solve this, and then when you get the answer, you multiply the answer by these coefficients. We have our third integral over here, and we can see that this thing kind of looks empty. So what do we do with this? Now you got to remember that whenever you have an empty integral, or you have an integral in which there is no x, then that means that you have an x raised to the power 0. And that's what we're going to do over here. So this is going to be 6, and then this is going to be x raised to the power 0. So we didn't have an x in the integral, so we just introduced an x raised to the power 0. And now this is going to be dx. Now you can clearly see that this is similar to our general form, and so you could solve it out. So we have our fourth integral over here, and we can see that again we have a term, we have an integral in which there is no x. And we just studied that whenever you don't have an x, you add an x term with a power 0. So that's what we're going to do. And so this thing is basically going to become this thing. I'm just going to write that real quick. And now what you can do is you can see that this thing is actually an x term with a coefficient, right? So what you can do is you can use the second integral property and you can take the coefficient outside the integral, and that's going to look something like this. And now you could see that this thing is now in your general form. You can solve this, and then whatever answer you get, you multiply that answer with this 10. We have our fifth integral over here, and this, I know this is already in our general form, but I don't really want to solve this one out. I just want to show you something that you can do with integrals. So this time what I'm going to do is I'm going to swap the upper limit with the lower limit. So it's the upper limit is 2 and the lower limit is 7, so I'm going to swap those two. And whenever you swap those limits out, your integral becomes negative. Okay, so when you solve this thing, you're going to get an answer. What you're going to do is you're going to multiply that answer with this negative sign over here. And I could take this exact thing back. I could swap the integrals again and it would become positive right over here. Okay, so for our integrals 6, 7, and 8, we're not really going to be using the integral properties, but instead we're going to be using some algebraic properties to convert this into our general integral right over here. So ideally what you want to do is remember, you're always trying to convert something into the form x raised to the power n. So that is your main focus, that is your main goal. So you're trying to manipulate your integral using algebraic properties and using the integral properties to convert it into this form right over here. So that's what we're going to do. Now we know that a square root means a power of 1 by 2. So what we're going to do is we're just going to write this differently, and this thing is going to become x raised to the power 1 by 2. Now we know how to solve this, right? Because we know our general form. So that's how we're going to now solve this thing right over here. Again, we're going to use some algebra for our integral number 7 to convert it into the form x raised to the power n, because that's what we're trying to do. So what we can do is we can kind of take this x down over here to the numerator, and hopefully that will do the trick. So we know that whenever we take a fraction from the denominator to the numerator, the sign of the power switches. So this is going to basically look something like this. That's our integral, and it's going to be x raised to the power minus 3, because we just took the denominator to the numerator. And of course this one is just going to multiply with this x, so you can kind of write this as simply x raised to the power minus 3. Right, so again we are trying to convert this integral into the form of x raised to the power n. So what we're going to do is we're going to use some algebra over here to simplify this integral a little bit, and that's basically going to look something like this. So it's going to be, if we multiply this thing over here and over here, we can simplify this a little bit and make it x squared plus 3x. And now what we can do is we can realize that, oh, we have a plus sign over here, so we can use the split integral property and split this integral into two parts, and that is going to allow us to convert this integral into the form x to the power n. So we are going to split this integral, so that's going to be this thing right over here and this thing right over here, and that's going to be our plus sign, and that is going to be x raised to the power 2. This is going to be 3x right over here, and then you can go ahead and solve this thing out. Right, so that's it for this video, and remember, you're trying to convert your integral into a simpler form that you can easily solve, which is this form right over here. If your integral is not in this form, then you have to convert it into this form using these identities and some algebraic properties.